It's really cute.
Yeah, in theory, we could turn the nominal power off like
Okay, it's not compensating hard enough.
It's pulling too tight, right? Too big a turn, right?
Well, I kind of want that. It's just not adjusting properly to it.
Yeah, exactly.
So it turns it off, doesn't reverse it?
No, we don't have it reversing. Although I could add that in.
The only reason you do that is if you want to make that inside curve.
Yeah, I don't think anyone could ever do that.
I fixed it so it couldn't ram the wall anymore.
Oh, my knees.
Like, yeah, they have like a spear on top of it?
That's nice.
Yeah.
That's done.
It's a good one.
It's just not turning hard enough to correct.
Why does it drift like that to the right?
It's trying to realign itself.
Stay close to the wall.
It's just not aligning itself hard enough.
Right, okay.
No, I mean, the bumper.
But it's going to leave.
It's a little bit longer.
Oh, is the sensor connected to the bumper?
Yeah.
That's funny. That's really good.
That's really good,
It will
actually.
always hit the bumper.
That's the goal. I just want to see if it can follow the wall.
Correct. That guy's going. Ross, you will fire yours up?
Okay.
I'd really like to catch that one.
Once more.
Here, yeah.
Not if he's making shenanigans.
Yeah, I did not catch it the first time, so.
The bull pod. Alright, here we go.
Okay. This is our final run. And then we're retiring him.
Yeah, we're retiring from the maze circuit after this one.
All right, on to bigger things. Exactly.
I'm not going to come back until you have the last hour.
All right, it's not that I'm a skeptic, but now that I'm now I'm actually recording it, I have my doubts. Oh, that's great. No, that is really nice, isn't it?
You could call it the bat bot. So I started thinking
The bat
bat
bot?
it back like the balls. It's not a bad idea.
Oh, that is better than I expected. That's great.
Oh my gosh. That was so good.
Narrowly avoided that one.
All part of
It
the
has
plan.
such a gentle touch to it. Doesn't push the 2x4s
Yeah, you
over.
wouldn't know by looking at it. It's very
Amazing.
gentle.
Well, with the low power. Yeah,
It's very gentle.
Okay, that really is good. Amazing. Great. Congratulations.
Okay, here we go.
You have to run the Lab 6 program.
Which one is the name of the other one that we just did? The one that moved.
Where are the other two robots?
They're actually fighting.
Ours will avoid all other robots.
Are the other robots coming? All right, here we go.
Yeah, that would have been
That's fine.
you knocked that off. That's like 10 points. That'd be a real taxing game.
10 points.
They're like little insects that get to attack.
Yeah, we got you in the sleeper hole.
Oh, this is great. Wait, I gotta get this. Wait, don't touch. Don't touch.
That's not fair.
Oh, look at that. All right, now you can break it up.
Deployable. You can drop them, like pop some fire.
Where are the other robots?
Nothing wrong with that.
Man, if only our bills were a little bit lower.
Come on, we're running out of time. Where are the other robots? Well, there's no time, guys. Battle ready. Okay.
We keep to ourselves.
That robot might be in danger.
Mine's not battle at all.
If he gets over there, maybe.
Oh, it's not?
Uh-oh, it stopped. It caught us.
All right, we're still missing a robot.
They're working together. No, get out of here. We don't want to work with you.
This front bumper. Okay. You got someone else in the party.
I don't know if it's gonna work. I just put new wheels on it.
That seems a little excessive.
Yeah, the wheels might not work.
Why is it too cold to send something?
Maybe.
Yeah, I don't think the wheels are gonna work.
It's inevitable. Oh man. Is it have wall falling on it?
Okay, that'll work.
Or does it have like a little more effective if they detected a robot? don't know, I just put one that seems to work.
Okay.
Of course it works.
Was it the compiler or what?
Oh yeah, the compiler wouldn't do it unless I had a small.
Okay, that's right.
You gonna use that track?
I was gonna check that one.
Okay, I'm gonna put the other track where it's accessible to everybody. It seems to be.
We should see if we can implement a line follower on the.
Woo!
I don't know if it can handle the hard turn so much.
You should be good.
Okay. This is a plus or minus 40 range, but black is about 300, and white is about 600.
Together into one
We're
video.
in the background of the line.
Whatever you just did made it really.
You're sitting on your butt. You're sitting on your butt waiting for it to come to you in one of them. I do recall that.
I think we have it turned a bit more. But I think
So tell me qualitatively about the gains. How much of each?
Well, the integral is the smallest.
Smallest is the integral,
It's
yes.
kept the smallest during runtime.
And the D is substantial.
The D is in the proportion are the same.
And do you feel like the D is contributing?
It's definitely minimizing.
The oscillations.
Yeah.
Oh.
Without the D gain,
Yeah.
we're definitely having oscillations.
Oh, that is great. I mean, that is absolutely the evidence that we didn't see with the line follower.
Yeah.
And so I'm even if this is all that happens, I feel like it's good.
Yeah.
I mean,
you can definitely tell after we put the D in, there was no.
That was close.
all right. So that's it. I think it's great as it is, but obviously tweak it some more if you want to.
Seriously, it worked.
We'll do like 3 pin for 3 pair pin.
We can make it faster, like just make it faster. It's not gonna mess with how things
I have everything else set to do.
I'm just your roaming reporter. I'm just here to spy. Everybody smile, I'm your roaming reporter.
Are you videoing?
I'm just getting the group pictures. Yeah.
Are they pictures or videos?
I want to get your robot in a few minutes. Absolutely.
Oh!
Well, we need something. We need something underneath so that way.
That might be more than $30.
Weight of.
I mean,
It's just nuts.
It's very bizarre.
It got like a little bit faster.
To make it lower. We want it
why is it so trouble now? It's random. Both wheels move random. But
Well, our robot is designed to kind of act like a monorail. It uses 2 ultrasonic sensors to sense the sidewalls of the track, and in theory it should just move straight across across the track here. I guess I'll start
This is PID control.
to keep it centered. Yeah, I better save it. It just, what it tries to do is equalize the difference in the distance values on the track for both ultrasonic sensors, and then it uses just regular PID control for calculating that error. Do you want to demonstrate your?
Yeah, I want to see the dog.
Yeah.
I mean, I'm in favor of PID control, don't get me wrong.
He walks along with it as it goes down the track.
It should in theory.
In theory, yeah. Doesn't go very straight.
Straighten him out. Okay, thank you guys.
Before we do it, because we got to turn off the lights for it, this little robot here is going to follow the line. But instead of just a line, it's a light. It's going to chase after a light. And if you make a very loud noise, instead of chasing after it, it's going to run away from it. Very simple, and it uses PID controllers to run.
Ah, coming to get me. Okay, yay! Wait, ready to go.
Okay, so ours is a bug, and one of the challenges of programming it was dealing with the legs, but it also it attempts to search out light with one less sensor, and it should run away from things it gets close to, and also randomly move when it hears a sound. So, yeah, at first it has to sync the motors so they are correctly oriented, the legs are oriented correctly. And the room's pretty bright, so it might not be under the threshold to do the
Seems to be pretty obedient.
Yeah.
Definitely.
How do we want to do this?
Yeah, and then if it sees something close, it makes a noise and turns and goes somewhere else. That's it.
Okay, thank you, guys. That's terrific.
Well, our robot is probably the only one that we didn't actually get to work the way we wanted to. But in theory, it was supposed to be a guard robot where you put an object that you want to guard in the center of a square, and the robot moves in a square, and at each corner of the square, it takes in values from the ultrasonic sensor, stores them in an array. So the first time through, it gets just the baseline down. The next time through, it does the same thing, but it'll measure each value from the array, and if there's something closer, it'll set off an alarm. If a loud noise is made, it'll set off an alarm, or if something bumps the front sensor, it'll set off an alarm as well. So, our robot's off.
It's sort of contingent on being able to
That's
get
all
back
right.
to its original
Look,
starting position.
look at what time it is. Does it look?
perfectly,
Yeah,
which-
it's 10 minutes after. We're not rushed, are we?
Yeah,
In fact, we're gonna make the next team. Next team has to take a half an hour. All right.
So obviously it doesn't move
So
straight
yeah,
away.
there may have been a hardware issue.
Oh, that's nice though.
Forward with the wheels.
Takes in values again.
See, the turn sort of.
We couldn't get the turns to be consistent.
Get him to turn towards me if you can.
It should. The issue is it just has this mean suspension.
Well, it saw you.
Yeah.
So.
Okay. All right.
We built a robot that plays fetch, so kind of with a little bit of babysitting. So we have a ball, and you can put the ball somewhere, and it'll go and it'll look for the ball.
Once it finds it, it'll hone in on it and line up this basket, activate the basket, and catch the ball. And then it'll do the same code to come back and find you, so then it'll release the
Find
ball.
somebody's leg and then
Yeah, release the ball back to you. And
set it because he does the chart first, so set him kind of.
he does a funky turn. Just throws them off.
okay, hopefully best.
The problem we encountered is we talked in the homework about we had the ultrasonic sensor that did 5 degrees at a time, and then it was like, okay, can we get it to go the full 180 and then just interrupt if we want to? And that's what we were trying to get to do, but it didn't.
Not yet, not yet.
Yeah.
See that remark?
Yeah.
Okay, so to get him to go, you have to say fetch. So everyone say fetch. 3, 2, 1.
Fetch!
Why not? There you go.
There he goes. Oh, he's actually kind of close to it. Okay, he's turned too much.
Yeah, so you kind of have to get him to line up with it because you can't, he isn't quite interrupted.
Yeah. The turning around code is not beautiful. This might be. Nope. Oh.
Yeah, he's probably moving a little too fast, huh?
That may be too.
Yeah. Let's put him down.
Yeah, he should have slowed him down a bit.
Get the code to execute. Nope, he's not doing it.
All right. Well, once again, you guys can take the next couple weeks to fine tune it if you're in the mood.
Okay, so this is.
Yeah, that's good.
Okay, just so I didn't see it. Oh, dang.
Well.
There we go. Just as soon as he moved it.
And so then he does the same search code to try to find somebody to get it to. And then he brings the page up and finds somebody. So.
The code is. The year is pretty close because we didn't know how much.
Well, you just said it. If you think it's pretty close, why don't you take that seriously? Hopefully, at least some of you will come by and get this thing patched up if you're in the mood. I hope. Okay. All right. Thank.